Hi, I'm Dion from CertMathsVideos.com. Now, we're asked here to show that dy dx is a constant. So first we have to get dx dt, and then we have to get dy dt, and then from that we have to maneuver what dy dx is. So we'll just start off with dx dt here. We know dx dt is equal to 6t minus 6. And then we know y here, we want dy dt is equal to 2 minus 2t. Now, we should know this using the chain rule that dy dx equals dy dt times dt dx. So that implies dy dx is equal to dy dt, which is 2 minus 2t times dt dx. Now, we need times dt dx, but what we have is actually dx dt. So what we have to do here is just invert basically. So dt dx is equal to 1 over 6t minus 6. Now, but we want to take out 2 as a factor at the top and then 6 as a factor at the bottom. So that is 2 into 1 minus t is equal to, over 6 into t minus 1. Now what we can't do at the minute here, 1 minus t. What we can't do in a minute here, we can't divide one term by the other because they're not the same term. So really what we have to do is, without changing it, we're going to multiply above and below by minus 1. So we multiply minus 1 over minus 1, and that is equal to 2 times negative 1 plus t, and then multiply the bottom by negative 1, we just multiply the 6 by negative 1 here. 6 times t minus 1. Now, what we have here, we have t minus 1 above and below, and any number divided by itself is equal to 1. So really what we have here is equal to negative third. And that's our answer there. dy dx is equal to negative a third, so that it's not a constant, so that's the solution to that question. Now, on the next question here, we're asked to differentiate this. We're asked to find dy dx in terms of y and x. Now, but you can't do this normally, because normally what we have a y term on the left hand side, and then the right hand time we have constant in terms of x's. But we can't do it here. We can't do y's and y squares. So what we have to do is differentiate it implicitly. So we'll start off here. X squared, we differentiate that number, that's just equal to 2x. Now, here we have a mixed term here including y's and x's. So we let 2x equal to u and y is equal to v. So that's u times dv dx, which is negative 2x. Times dv dx, which is just dy dx, plus v times du dx. Now v is your y here, and the derivative of negative 2x is negative 2, so that's negative 2y. Now here we are, plus 6y times dy dx. And this is equal to plus 4 times dy dx. And the derivative of constant is always equal to 0. So now what we want to do here, we want to get every term that has a dy dx term in it on the left hand side and all the other terms on the right hand side. So we'll take out dy dx as a factor. So dy dx now into, we have negative 2x, and we have plus 6y, and we have plus 4. So that is this term here taken care of, this term here taken care of, and this term here. So what we have is 2x and 2y is equal to 2y minus 2x. Now, what we want to do here is we want to get the dy by dx on its own, so we're going to divide both terms by this term here, or both sides of the equation by that term here. So that implies dy dx is equal to, but I'm going to take out 2 as a factor as well as divide it. So it's equal to 2 into y minus x all over 2 into minus x plus 3 y plus 2. And any number divided by itself is 1. So 2 divided by 2 is 1, we just get rid of that there. So that implies dy dx is equal to y minus x all over 3y plus 2 minus x. Now, the second part of the question here, that's actually correct for that one. The second part of the question here asked us to show that 2 points on the curve, that their tangents are parallel. Now we'll know if the tangents are parallel, if their slopes are parallel. So you don't have to work out the equation of the tangent here at all. All you have to do is work out the equation of the slope. So at two separate points. So basically what you want to do is you want to sub one point into this equation and that'll give you the slope at that point. And then you want to substitute the other point in that equation and that'll give you the slope of the other point. And hopefully if the lines are parallel, the slopes will be the exact same. So our 2 points are, our first point is -3, 1. At the point -3, 1. Remember when we differentiate something we find its slope. So this is the slope here. So the slope at -3, 1 is equal to y, which is 1, -3 is positive 3, all over negative x, which is 3 plus 3y, 3 plus 2, and that is equal to 4 all over 8, which is equal to a half. So your slope at the point -3, 1 is equal to a half. So there's no point finding the equation of tangent because there's just y equal to half x plus whatever. So now we have another point here is 1, -3. That's right, at 1, -3. So we have y minus x, which is -3, minus x, which is -1, all over negative x, which is -1. Plus 3 times -3, which is -9, and plus 2. So -10 plus 2 is -8. So we have -4 over -8, which is equal to a half. So that implies the slopes are the exact same at both points. So that means their tangents are actually parallel.